Actually, yeah, I'll call it translations. Today all we're doing is translations. So the big unit or the big topic is transformations, which is move up and down, move side to side, stretch it out, reflect it. Today I only want to talk about moving side to side and moving up and down. That's it. So, let me start with something. Imagine I said f of x equals x squared. Imagine I said f of x equals x squared. And then I said the following. G of x equals f of x plus 3. So I've got f of x equals x squared, and g of x equals f of x plus 3. How could I write g of x so that this f of x wasn't there anymore? How could I rewrite the equation to sort of get rid of this f of x, right? What do you think, Iris? Yeah. Because f of x is just x squared, so I could just say g of x equals x squared plus 3. Any questions with that much? And now, let's do the following. Let's graph f of x and g of x. So let me graph f of x in orange here. So we all know what f of x looks like. We all know f of x looks like this. Everybody knows this. If you want, you could have built out a table of values. So x, f of x. You could have said, okay, when I plug in 0, 0 squared is 0. You could have said, let me plug in 1, 1 squared is 1. You could have said, let me plug in 2, 2 squared is 4. You could have done -1, and so on, right? I mean, I think everybody can build a table. And we would have gotten a graph that looks like a little bit more symmetrical than mine, of course, right? It should actually be symmetrical. In fact, let me make it a little more symmetrical. Right. Okay, now, if we want to graph g of x, we would do the following. Let's assume we had no idea how to do it. We'd build out a table. So x, g of x. So when x is 0, 0 squared is 0, plus 3 is 3. When x squared is 1, 1 squared is 1, plus 3 is 4. When x is 2, 2 squared is 4, 4 plus 3 is 7. If I plug in -1, -1 squared is 1, 1 plus 3 is 4. Questions so far? So let's draw these out. So instead of 0, 0, I now have 0, 1, 2, 3. Instead of 1, 1, I now have 1, 4. Instead of 2, 4, I now have 2, 7. You all see where this is going. So this plus 3, so what did the plus 3 do to the graph? What did the plus 3 do to the graph, Daniel?
It shifts the graph up 3
It shifts
units.
the graphs up 3 units. This is called, as you all know, a vertical, right? Translation. Fernando.
Is the distance between the two lines 3 units?
Is the distance between the two lines 3 units? Is the distance between the lines 3 units? Yes. The distance between 2 points with the same x value will be 3 units. Yes.
What about different?
There you go. Good question. So, of course, vertical translations don't always have to go up and down. I could have the following. I could have said f of x equals x squared and g of x equals x squared minus 4. right? This would still have been a vertical translation, except we would have gone down 4. We'd have gone down 4. Questions on that? What if we said, can we write g of x with f of x as a part of it? In other words, write g of x to look a little more like this. How would I do that? How would I make g of x look a little more like this one as opposed to this one? What do I want to do? How could I write g of x so that it looks a little more like that? There you go.
Instead you would write g of x equals f of x minus 4.
Yeah. Because x squared can be rewritten as f of x. So I could just say g of x is this, or g of x is also this. Same thing. Either way to write it is fine. Both times this is indicating down 4 units. So vertical translation, the key thing to take away are 2. One is the translation, this number, if you notice, is outside of the argument of the function. Less mathematically, the transformation, what's like, Javier? This transformation, the down 4 units, doesn't affect the x. This has no effect on the x. It comes after the x, so it only changes the y coordinate. Vertical transformations only change the y coordinate. Javier.
So it would just be basically the indicator of the direction with the vector.
Yes. So if it's minus 4, we go down 4. Plus 3, we go up 3. Now, can we tilt to the other board, Lucia? Now, we could also have horizontal. We could also have horizontal translations. Looks like the following. So we have f of x, let's pick a different one, square root of x. So we have f of x equals the square root of x. And we'll say g of x, or you can call it h of x, any letter you want, doesn't matter. Let's call it g of x.
Z of x.
Equals f of x minus 5. Okay, this is a little bit harder, but let's see how we do on this. How can I write g of x without being in terms of f of x? Can anybody see this? How do I write g of x so that it is not in terms, Sergio Ayala, of f of x?
It would be g of x equals the square root of x minus 5.
Do you want the 5 under the square root or outside? Under. That's absolutely right. That's absolutely right. And if you're wondering how we got that, it is just like what we did before. If I say f of x minus 5, that means take x minus 5 and plug it in for x. Just like before, when we had f of 3, we took 3 and plugged it in for x. Or when we had f of 10, we took 10 and plugged it in for x. That's all we're doing here. So now this, bless you, is a horizontal translation.
Stop the recording.
Hmm?
Stop the recording.
And then restart it?
Yeah.
Okay.